Hi, my tutorial is about coroutines. So what is a coroutine? It allows tasks to be spread across several frames. It's a method that can pause execution and return control to Unity and continue the execution on the following frame. So what happens without a coroutine? When a method is called, it runs to completion and returns control along with any return values to the calling method. This means that any action that took place within the method occurs within a single frame rate. For example, this means that something such as shrinking or fading an object will occur, it seems to be instantaneously, when that is not what we are trying to do. So when would you use a coroutine? When you want a method to contain procedural animation or a sequence of events over a period of time. The example I will be showing today is shrinking a game object gradually until it disappears. So I will be shrinking a sphere on a plane until it disappears. And we will show that before using a coroutine, you are not able to see the shrinking and it happens instantaneously. However, with the use of a coroutine, you are able to witness the shrinking. So our first implementation begins with a shrink method that I've implemented that will be called when the S key is pressed. We get the current scale of the game object from the local scale and then the current X value. We use a for loop in this example because the sphere has the same scale for the X, Y, and Z values. And we decrease the X value of the scale and therefore also the Y and Z values using this for loop to subtract 1 every time and update the local scale. So here, if we save this, we can see how this first implementation looks. So here we have started the game. And if we press S, you can see that the shrinking happened instantaneously. The sphere has disappeared, but we also did not see any of the shrinking animation that we want. So to use coroutines to fix this, we have a new implementation here. So we still use S to call the shrink method. Yes. We still use S to return the shrink method, and we still have the same for loop. The largest changes here is the use of the I enumerator, which is the return type of a coroutine, and the yield return null that is featured here within the for loop. So those are two specifications of a coroutine that are shown here in order to make use of the coroutine and show the shrinking animation. Coroutines also, in this example, it doesn't really matter because all we're doing is shrinking the sphere, but you also can call stop all coroutines or stop coroutine with the specified method. So here we have that where we can stop the coroutine by pressing E. So if we give this implementation of a coroutine a go, here we can see that when we press S, the sphere does in fact shrink. It happens very fast, but not instantaneously, and we are able to see that the sphere shrinks. Another thing that a coroutine can do is instead of using the same yield return must always be used, but instead of returning null, we can use wait for seconds method. And for example, just give it 0.1. Have to call new. Yep. And now when we save this and run this. When we press S, you can see that by adding that 0.1 second delay through the use of wait for seconds, that is called every single time this for loop occurs, you can see there is a pause in between each shrinking of the sphere. So here we see again, it's not shrinking the most gradually due to our pause, but we can actually see the shrinking occur now. So we can also show our use of the stop all coroutines here by running it one more time. And I'll press S to start it, and then I press E right here. You see I stopped the coroutine, and I can then once again press S to continue and finish shrinking that sphere. So this was just a quick example of how to use a coroutine to have a sequence of events over time, and in this case, show the shrinking of an object instead of it happening instantaneously. And once again, some larger takeaways is that the coroutine will always have a return type of I numerator and a yield return, which can either return null or, like we shown here, the new wait for seconds.